As sir explained, like we are going to learn today about the machine learning part, in the machine learning, how what is the concept behind the machine learning, and how do we implement machine learning in the industry, considering the industry concepts. And we are going to learn for 3 to 4 algorithms, which are majorly we utilize in the industry for making any use cases, considering classification problem or regression problem. So example, if you want to predict the gold price for the next 10 days, so we will use the regression concept. So these are the kind of concepts which we are going to learn today with the hands-on experience, with the Python programming language, and with the Excel also, which I'm going to show for one of the algorithm. Okay, so I'm sharing my screen quickly. So before I jump into the other concepts, so let's understand the what is machine learning. Okay, so in machine learning, so machine learning is a subset of artificial intelligence. So the developers, who want to wanted to have a start a career with the AI, so they must have to know the machine learning concepts. Okay, so initially whenever we create the developments like in a machine learning AI model, so we starts with the machine learning. Okay, then we go with the deep learning, then accordingly based on the requirement, we implement the gen AI. Okay, so these are the three subset, the core concept for the AI, the program. Okay, for any developer who are working into the AI field or data science field, okay, the job titles might be vary, but the way of the nature of the work will be the same. Okay, so today we are going to see more insight on the one of the subset called machine learning. Okay, so what is machine learning? See, by seeing this word itself, we know that okay, we are going to train the machines, okay, with the by using the complex algorithms. Okay, with the complex algorithms in the sense of complex mathematical expressions. Okay, so here we are not going to write any mathematical expressions, so that expressions will be implemented with the Python programming language. Okay, so for that, generally for implementing any machine learning algorithms in the industry, we use scikit-learn. Okay, we use a scikit-learn program. Okay, we use a sklearn. Okay, so generally people calls scikit-learn. Okay, so scikit-learn is a framework which we use in industry. So anyway, and if you want to implement machine learning concepts, so this is the one of the framework which will be available in the Python. Okay, we will install this package. Okay, with the pip space install and scikit-learn. Okay, so by using this command, so we will install the scikit-learn package, and once it is installed, so we are ready to implement machine learning algorithms. Okay, so before I jump into the machine learning algorithms, as I said, this is a one of the subset of the machine learning into the AI, right? So generally, what it do, and what we perform when, and if we consider, we have taken the some problems set of predicting the gold price for the next 5 days, or gold price for the next month. Okay, so we wanted to implement this future predictions with the machine learning algorithm. So we know that because we what we do, as we are the A developers, we collect the historical data. Okay, we collect the historical data. For example, if you by seeing this Excel, you can see there are two futures. Okay, one is a year of experience and salary. So consider similarly, you will be having the gold price as well. Okay, so you will be having for the gold price. Okay, let's take new sheet. Okay, so you will be having the date, okay, and the gold price. Okay, gold price along with that. Okay, so for so generally we see the gold price based on the the kind of the region to region, which will be the gold price will be vary, right? So consider the location or region. Okay, region might be the India, UAE. Okay, or like in USA, or you consider like in UK. These are various region. Like consider the gold price, it might be $700. Okay, 710 or 715, like 705. Okay, again, if you consider for the same reasons, okay, so again you will be taking the same price, right? Like in the price will be vary. Okay, and you can give the dates as well, like in a 1 12 24. So here you see that for considering for the dates of December, okay, December month, January month, okay, for 12, 13, 14, 15, 16, these are the dates, okay, for 7 days week if you consider. So these are the gold price, okay, which is in the market. So with the various regions which you can consider as well. So here my business statement, I want to predict, I want to predict, I want to see the gold price for the Jan 25th, or like in a from Jan from Jan 20 to, okay, Jan 30th, okay, for 2024 consider. Okay, this is my problem. What is my problem? So my problem set is to see on the gold price, okay, for the next 10 days. So when we see that, like, we are going to do the, we are going to calculate the gold price information. So whenever we get the historical information, okay, they have given the historical information of with the various futures, and they have given the gold price. Okay, so here this is our target variable. So consider gold price is our target variable, which is presented in the given input data. So if you can mark it as an yellow mark. Okay, and the A and C columns are the futures. Okay, so you mark it as an another color, like some blue color. Oh, it is okay. So here you see that A and C we can consider as the input futures, and B you can consider as a the future which you wanted to predict. That is called as a target variable, or like the prediction variable. Okay, so dependent variable we can call also. Okay, so when you have any data, when you know the input and output, you wanted to predict this the gold price. Okay, so with the basic algorithm which we wanted to perform is generally we go with the machine learning. If we wanted to predict the gold prices with more accurately, okay, which more accurately, then we go with the deep learning. Okay, the deep learning subset which will be used when we want it to be the prediction should be 99%, the prediction should be have to be right. Okay, then those cases we go with the deep learning. Now if we are okay with like an 80% or 90% is also fine about our results, then we go with the machine learning. Okay, so for that, what we do in the machine learning or deep learning, we will be having the both input features and the targeted variable information. Now here, so when we see that, when we have an input data, like when we are having the business data, both input and output. Okay, when we have an both input and output. Okay, this we call as a supervised learning. Okay, when we see in our data set like in both input and output, then we consider as a supervised learning. Super like machine learning is also having a three subset. One is supervised and unsupervised, okay, and reinforcement. Okay, so these are the basic three concepts belongs to the machine learning. So as we know that machine learning is a subset of AI. Okay, and when we go with the subset of machine learning, again inside the machine learning we have three more concepts which basically we utilize to implement the machine learning algorithm based on the given problem set. Okay, so when you see that this is a supervised learning and unsupervised learning and reinforcement learning. Okay, so in interview also they ask you, okay, so what are the supervised learning? What are the parametric and non-parametric algorithms? So how do you implement the unsupervised learning algorithms? Okay, how do you implement the reinforcement? Basically, many of the industry, they look for the challenges to resolve with the supervised and unsupervised approaches only. Okay, so today we are going to learn with the supervised approach. Next session will plan for unsupervised specifically. So what type of algorithm will be presented and how to apply those algorithms when we don't have any output information in our given data. Okay, then we see the unsupervised. Okay, now let's focus on the supervised only. Okay, so supervised is a one of the subset of the machine learning, right? So in supervised, what will happen when in our historical data you will be see input and output. Okay, when we see the input and output information in in our historical data, then we can consider that that particular problems will comes into the supervised learning approach. Okay, so when we see in our historical data the input and output information will be presented, then consider to be the supervised. See, we always have to think as a developer, as an if you are the software engineer, or if you are the data scientist, or you are the AI developer, when you are coordinating with when you are coordinating with your business stakeholders, they will give you simple like in the problem statement. A user like an a I have an one data one I have a one problem. Okay, so kindly resolve with could you kindly resolve your with the data science skills. Okay, they will ask you and they will tell you. Okay, see, we wanted to predict the number of users are going to be present in our location in the if you wanted to if they are planning to suppose consider their the team is planning to launch new product, so they wanted to analyze. Okay, if I launch the particular product, so who are my targeted users? Okay, who are my targeted users? So then what we do, what we see, we go back and we see our existing product. So in existing product, who are the customers which has been purchased this product? If this product is also similar like their new product, okay, then we can promote this particular product to the existing users, right? So your managements will provide the information. This business information will be like these statements. Okay, as you are the data scientist or you are the AI developer, now you need to think. Now you need to think and analyze. Okay, in my problem statement, I already have any specific product. Okay, and I need to find out the my users information. Okay, so here the users are the customers. Okay, so suppose you will having the various customers that has been categorized into three class A, class B, class C, based on the financially they have spent it for the particular product. Okay, so then I know in my data, so I have a output information. So I know my targeted variable. So the target variable is also present. Along with that, okay, to be purchasing this product, okay, in what are the days, in which days or from the which location the people are shown more interest. So with this basic information, okay, with this basic information, we can consider as a input features. Okay, these are input features. Okay, I know that my user, this is XYZ user, you can consider. Okay, this is my XYZ user. User is your target variable. Okay, you have to find all the users. Okay, all the users list like this. Okay, and you have the various information like location and the product. Okay, and along with that, like the amount they purchased. Okay, and along with the previous previous product details as well. Okay, when your managements are discussing with you, so they will provide this these are the kind of information. So from these informations which we need to identify that, okay, we are going to get the both input and output information. So then I'm going to target my users information. Okay, here I'm going to target my user information. Then I can consider that this problem will comes under into the supervised learning approach. Okay, supervised learning method, because this particular method will have the both input and output mechanism. Okay, for unsupervised, you will have just only one input. Okay, so you won't have any output variables here. Okay, in unsupervised, you just have the input features. You will be having just input features. You won't have any output features. So from our analysis, we have to identify the output features by using the unsupervised learning technique. Okay, so let's focus to the supervised. So now we identified that whenever we implement the supervised, or whenever we consider the supervised learning, so in supervised learning we will be having the both input and output variables. Okay, that's we call as a supervised learning. So as I told you, the machine learning is a subset of AI, and these machine learning algorithms can be developed with these three concepts like supervised, unsupervised, and reinforcement learning. So in supervised, so whenever we are considering as a this is a supervised method, means based on our data, will come to the one conclusion. These particular problems will comes under the supervised bucket, because in my data I am seeing the input and output features are presented. Like as you see here, one of the example salary data. Okay, so you suppose you are working for some HR industry. Okay, so you have to predict the salary. Okay, you have to predict the salary for the employee. So how will you predict the salary information for the particular employee? So based on the considering for the employee, based on his experience, based on his skill set, and based on the companies he worked, the domain, and along with that, okay, about his qualification, and along with the what are the multiple skill set which is have. Okay, and as per the market and as per the organization, by considering the various features, we can tell that these particular experienced persons with these xyz features, we can give the salary in the range of like some 100K to 150K, or 120K to 140K, or like by giving of 80K to the some 120K. So this is how we'll predict the salary ranges based on the given information. Okay. So here you see you will be having the targeted information as a salary, because you are predicting the salary, because and this is the experience. Here we are considering only the two features. Input is in one is the independent feature, another one is the dependent feature, that is we call as a target variable. So with the only experience, because you consider in any company, as if you start as a fresher, as in a 0 years experience, we only get the standard salary, right? Because every company have their own constant salary. So with that range only they will be provided you. As soon as the experience which will increases, you can see that, see 1.1 experienced person is having 39343, and 1.3 person is having 46205. So you can see that the experience, when you're considering, okay, it is increasing the packages as well. And but you see, even though this particular person having the 1.5, but his salary range was less compared to the 1.3, because the skill set, as I told you, to finalizing the salary information. So with the only experience which we cannot consider as a this is the final salary range, we have to take in for the other features like an e skill set, like whether he's working on the PHP program, or whether he's working on the Java, or whether he's working on the .NET, whether he is working on the R. Okay, we'll consider with the various programming language, and particularly with the terminologies, then we can provide his salary structures. Okay, like this you can see the data. Okay, so each and the experience which is getting the salary range is also going 6.8, you can see that 7.88, 9. So it is almost now 6 digits number which is crossed. Okay, as soon as his experience is around 7 to 7.9 to above the 7.9, you can see the 6 digit numbers which is crossed. Okay, this is how we just will analyze the basic information by understanding the various features. Okay, which features are required for to analysis for our target variable. Let's consider. Okay, let's jump into uh, the slide. So here you can see, as I told you, these are the three core concepts in the machine learning algorithm, like supervised and unsupervised, and reinforcement. And in supervised there are like a regression and classification. Again you will see the two more concepts in supervised. So the problems here, okay, 1 to 1 and 1 to 2. Okay, if you have any queries, please feel free to message in the chat room. So I will try to address you the answers for those queries once the session is completed. Okay, and you can see that regression and classification. Okay, so in supervised also, as I told you, when you see the input and output features which comes into the supervised learning algorithm, supervised method. In supervised method also, there are multiple algorithms. See, each and every algorithm will work on the specific. consider consider in our family, okay, in our family, our brothers and sisters are there. Consider if you have a brother and sister. So you're studying as a computer science engineer. So basically you will become a programmer, right? So consider if our brother is doing is an MBA, he might be expert in the finance and or marketing, right? If our if one of other brother, if he's working on the pharmaceutical, like in a B pharmacy or M pharmacy, related to the the industry, then he might be he might be into the healthcare industry, right? Specifically into the developing the drugs and analyzing and understanding about them in detail of the medicine information. So similarly, okay, when we see the information, when we discuss about our data, so these output targets, so these targeted variables, okay, what kind of the targeted variables which we are going to perform. So based on that, we need to identify that whether this particular problem will falls under into the MBA category, or the problem will fall into the program category. Okay, because you see that, right, each and every these particular persons will have their own domain experts, right? So similarly, by considering in the supervised also, there are two concepts called regression and classification. Okay, regression and classification. So in regression you can see the targeted variable. So this is if you consider the targeted variable. Okay, in the target variable you will see the continuous values. Okay, see, as I told you, as a salary, this is one of the good example for the regression. Like, as soon as we are getting the more and more experience, every year we expect some salary should be hike, right? The salary should be not constant every year, because as the experience is increasing, we expect the salary also to be increases. Similarly, these are the this is the one example, like as from the 1 year of experience to 10 year of experience, if you see, there might be the salary range will be the different. Okay, each and every year and each and every month, if you consider, so the salary range will be the different. Okay, so these we call as a continuous values. Even you can consider the gold price. If your manager want you to make a model, so that particular model need to be predict the gold price for the next 1 month. Okay, means each and every day, because each and every day the gold price will be vary, right, based on the market, market sustainability, like and how the market is there. Okay, so based on the various, like, and if there is a US marketing, okay, how the US market is there. Okay, the dollar rate, how it is converting. Okay, and how is the UAE kind of like, and where we get the more the gold is from the some XYZ country, means we see the financial informations of the particular country as well, how it is continuing. So with all the factor, we can tell that, okay, the gold price will be varies on this particular day. It might be the $710, and the next day it might be reached to the $715. Means you see that there is a $5 difference from the day one to next day. Because there I see that, like, there, because of this market, I see that the dollar price is getting increasing. Okay, then they might be having a chances that gold price is also going to be increase. Okay, so this is how we see the difference. This is how we see that. So each and every day the gold price, like in a one day will be 713, another day will be 715, another, and the next other day will be the 720, and another day will be the 721. If you considering for the 1 month, each and every day the values will be the different. So when we see those continuous value, we consider as a regression problem, like 710, 711, or 70706, 720. Okay, so these we call as a continuous variable. Okay, so now this is because as your business statement is said that they wanted to predict the futures, they wanted to predict the numbers, okay, for the given day or for the given month or for the given week. Okay, continuous. Okay, so those we call as a continuous values. Okay, whenever we see in our data, Okay, we will identify that this is the data which we wanted to predict. So that data will be in the continuous or, okay, continuous or binary information. Okay, so we'll see with this the continuous or discontinuous it is there, informations will find it. Okay, for classification we predict yes or no, yes or no, or like an you can see one or one zero. You can sometimes you can see that like an multi-classification 102 it will be there like an either true or false. Okay, so in your data sets, for considering the same gold information for gold company which you are working, so your manager is asked one more problem statement as well. Instead of price, I want to know that whether the next day for the next 1 month, how will be the goal structure, like, and it will be the price might be the high or the price might be the low. Okay, only the two information, high or low. Okay, then we see that like this is the statement which we wanted to predict. Then we'll think that this particular problem has to be comes under the classification approach. Okay, so this particular problems will comes under the classification approach. Okay, when we see the binary information, these are the not the continuous value in your target variable, so it will be the only one or zero. Like you can consider, I will show you some example data sets as well. Yeah, yeah. You can see that this is a purchased variable, whether the user is going to purchase the vehicle or not. If this purchased, it will be marked as a one. If the user will won't purchase, it will marked as a zero. So you need to predict the, if you are launching for any vehicle or if you're launching for the product, so the whether the user, like, and if you're considering for your existing user, whether this particular user is going to purchase your product or not. Okay, with this informations which we are going to do, so in our target variable, if we see the information as an yes or no or true or false, okay, okay, then we can consider that it is in a binary classification, then it comes under into the classification category. Okay, so we should be clear even in the in your interviews also. Hey, could you walk me through the few algorithms related to the regression problem? Okay, hey, could you walk me through the problems related to the classification? So we should be clear. Okay, which problem statements will comes under into the classification, or which problems will comes under into the regression. So based on that, we can tell that these are the algorithms will help, which will helpful for making our analysis for further. Okay, so this is what we need to see that. Let's jump into that. I hope you people are clear with this concept now about the machine learning. Inside the machine learning, we have seen that supervised and unsupervised and reinforcement. So then we have started with the supervised. So whenever we work with the supervised category, we identified that the given data will be having both input and output variable. Okay, so we will have the both input and output variable. Then the next information, this is the checklist which we need to see. As you are the developer, whenever you receive the statement of the problem, first you have to prepare your checklist. Okay, this particular checklist, which if suppose they wanted to make it with the ml approach only, so this checklist you have to see whether this particular business statement will fall under into the supervised or unsupervised. Next step you need to verify that. Okay, then which, if we consider the supervised, okay, it comes into the another which category it will comes, like in a regression or classification. This is a second checklist. The third checklist, okay, what are the algorithms which we have into the particular category? So pick up few of the algorithms and doing of some POCs and finalizing the one algorithm. So that's how the AI developer will do that. That's how data scientist also will think of that. Okay, so these are all the checklist information which you can consider now. Okay, so as I told you, these are the linear regression and logistic regression and decision tree and random forest, support vector machines and support vector regression and bagging and boosting KNN algorithms. So these are the algorithms which we use in the industry for whenever we wanted to implement in the machine learning algorithms. Okay, so even you go for every industry, even if you attend for any interviews, they ask you the major algorithms, because many of the problems can be solved with the decision tree or random forest. Okay, or bagging and boosting algorithms. Okay, like bagging and boosting algorithms, which is a combination of the multiple models which we can say that we are going to learn, and along with the logistic regression. Okay, and navi base also people will use, like in a, so those are common 10 algorithms will be there, but majorly we utilize in the decision tree, random forest, bagging and boosting, knn algorithms. Okay, so linear regression. So these are the major algorithms which we can consider. Okay, so as you are attending for the interview, please be prepared for these algorithms, and they will ask you in detail how these algorithms will work. Okay, in the background, like, and if we know that, like, with the python program, with the 3 lines of code, we can implement the algorithm. But as soon as we are feeding the data to the machine learning, we need to identify that, right? How this data it is been converting to the numerical, from the numerical, how the machine learning algorithms is trying to identify the patterns. So to identifying the patterns, what were the behind the mathematical, logical, or mathematical functionalities which we are applying, which, as you are the data scientist, which we need to know. Okay, they might be ask you these questions as well. So I will teach you, okay, what is the various the parameters which you are going to use, and with that parameters I'm going to connect with the mathematical modules, like in how we generally, because we already have studied in the various mathematical operations, like in a cosine similarity, and along with the dot product, and calculating the finding the distance between the 2 points. Okay, so these are the kind of the concepts which we are going to utilize in the machine learning as a basic approach, like in a matrices, which everyone knows, like in eigenvectors and eigenvalues. So this all will comes under into the machine learning algorithms. Okay, inside the machine learning it will learn. Okay, but just we need to know the, okay, if I apply this particular parameters, okay, this will connect it to the backend mathematical approach, and it is going to perform various logical operations. Okay, no need to go in detail. Okay, no need to go in detail, but at least we need to know the mathematical norms as well. Okay, so let's quickly jump. Okay, you have seen this. These are the supervised and these are the unsupervised learning, like K means and PCA, principal component analysis, and non-negative matrix factorization, LDA, latent digital allocation algorithm. So there are various algorithms will be available. DB scan is also one of the algorithm in the unsupervised learning. Okay, so today let's jump into the supervised. Okay, so here you see that. So basically we identified that, like, and when you have the input variable and output variable, we have seen the supervised. So we are going to perform the various operation, like in creating the embeddings, and then we will perform. So let's take one of the algorithm called linear regression. Okay, so before we are going to the linear regression, will try to identify the problem of our information. Okay, okay, consider you are working for the like in one of the project. Okay, one of the project. So like in a company, as you are the AI developer or data scientist. Okay, so HR management want one system to identify that if I'm going to hire one person, if I'm going to hire one person, okay, what would be the salary can be provided, what would be the salary range can be provided for him. Okay, so this is the basic information which they provided. Okay, so then we, as you are the AI developer, okay, we can identify that. So my information, like my targeted the focus variable is salary. Okay, so I'm going to find out the salary for the based on the employer experience. Okay, so consider here is the one of the major the input variable. You can consider important variable as a years of experience. Okay, we are just taken the single input feature. Okay, we are taken the single input features, but in the real time in the industry you might be you'll be encountered with the multiple input features. So that input features will be the 30, 40, 60, 100 features also will be presented. Okay, So with the 60 to 70 features, you have to identify the targeted variable. Okay, so this is the input feature. Okay, and this is the salary will be the targeted variable. Okay, so you can see that the first clear checklist is that by seeing of these data sets, we can consider that we have input and output. So this will comes into the supervised learning algorithm. Then we will see that this particular targeted variable, which is having the historical target variable, which is having the continuous values, because see, as each and every row which I'm going, so the values are different. So then we can consider that this is the continuous problem based. Okay, so continuous problem based, when we see this continuous problem based, this will comes under the bucket of regression approach. Okay, regression approach. In the regression, as we see that there are multiple algorithms like linear regression, polynomial regression, support vector regression. Okay, and decision tree regression, random forest regression. Okay, KNN also we can use for both regression and classification. Okay, these are the various regression algorithms which are available. Okay, when we see our targeted variable will be the continuous values. So now let's consider one algorithm. Okay, let's consider one algorithm in the machine learning for the regression problem as a linear regression. Okay, everyone knows the linear regression, right? Like in even our 10th standards, 9th and 10th standards also, we have learned the linear. Linear is nothing but what is happened. It is in a combination. It is in a combination of both independent and dependent features. Okay, then we call as a this is a regression, linear regression, right? So you see that our user, if your independent variable is time, and then you are forecasting your futures. Okay, so this is we simply call as a linear regression. Okay, linear regression means you will be having the independent and dependent features. Okay, that we call as a regression. Now let's see. Okay, to be implement the regression, to be implement the linear regression, so you will be know that like there is a problem of mathematical formula called y equal to mx plus c. Okay, y equal to mx plus c. Okay, y equal to mx plus, we see that, right? Even this particular formula which we learned in the our 10th standard as well. Okay, don't confuse with your simple linear regression or multiple linear regression. Okay, so here the concepts we are learning on the linear regression itself. Linear regression is only one algorithm. In our data set, we have taken as a one feature. We have taken as a one independent feature. That's why we call as a simple. When we use multiple independent feature, multiple inputs, then we call as a multiple. Okay, multiple linear regression. So no need to confuse on that. So it is comes under the linear regression only. So the formula will be the y equal to mx plus c. C is nothing but the constant. So consider the constant, like as I told you, in every organization. Okay, as for the starting of his career, like if they are hiring for some freshers, they will be see the for the freshers. So this is the package which can be considered. That is the 35,000 or 40,000 based on the company norms, right? So that we call as a constant. Constant means nothing but the C value. Next is mx plus mx. Okay, x is nothing but your input feature. That if you have any multiple input features, you can see that x1, x2, x3, x4. So here one feature, like in single input feature I have taken, right? That's why you are seeing the x1. M is nothing but the coefficient. Coefficient is nothing but like we are going to take of the average of the the values. Then we will going to calculate. We are going to perform some other mathematical operation. Then we'll find the coefficient value. Okay, that I am going to show you for this linear regressions with the Excel. How we apply this mathematical formula and we'll predict the futures. Okay. So you can see that y equal to mx plus c. So this is the basic formula in order to calculate the prediction futures with this linear regression formula. Okay, so as you are the developer, when you are implementing with the Python, you no need to know about, you are not going to apply y equal to mx plus c. Just you can going to simply are going to implement your linear regression formula like in the package from scikit-learn. Okay, import regression. Okay, import linear dot regression. So with that you can implement your regression algorithm, and simply you will keep you will fit the data. Like fitting means you are going to pass your input and output features, then you will start training. Okay, that's all. There are only the two lines of code which you are going to run. Okay, but backend the data will be considered and it will be converted to the various numerical values. Anyhow, we will going to send the numerical values. That numerical values will be calculated with the what is the constant value, what is the coefficient value. Then everything once it is calculated, then it will find out the y variable. That is called the dependent variable, future prediction variable. Okay, let's see. Considering the salary, the problem itself. Okay, so here itself, the place symbols which you can see, these are the historical data. These are the historical data. The below line you can see that this is a x and this is a y. The x you can consider the years of experience, and the y you can consider the vertical line you can consider as the your salary range. Okay, so each and every experience you can see that this is a 0. Here you can consider this is a 1 year experience and 2 year experience, like 1.2, 2.3, like 1.50, only 5 months of experience. 7 years, 7 months, 7 years of experience you consider. Okay, now, okay, so here you see that this is the base price. Okay, for 0 to 1, if anyone will comes with this range, they are fixed with the one package. Okay, they are fixed with the one package. That is called as a constant variable. As I told you, right, 30K salary you can consider this is the constant variable, like you can see that. Okay, so here b1, like in the coefficient value which you need to consider. For calculating the coefficient, we need to know the mean of the dependent variable. Okay, from the dependent variable we are going to add the constant, then we are going to get that. Okay, so I will show you in the how to calculate this coefficient value as well. Next we are going to see that, okay, this is the constant value. For anyone will comes into the 0 to 1 with the 4 months or 5 months, or even if the person is having 0 years, then we can consider as a 30K itself. Okay, so then as soon as the experience which is increased, like in 1 year, you can see that from, if you are considering here is a 30, so here you can consider that 40 or 45. Here you can consider as a 50 as well, like if you consider this one. Okay, so the as the experience is increasing and the salary is also growing. Okay, you can see that here, from the 1 year of experience to 2 years of experience, which is came from 30K to 10K, which is increased. Okay, that is the one difference which we can see that, because if if the person is having more experience, the salary will also will be higher. Okay, next, to implementing the linear regression in programmatically. Okay, first step, we need to collect the data set. So, and the next step is to pre-processing the data sets. So as we received from the data sets from the management. Okay, this is two columns like in A and B. So we have the data sets. Next step is the step one is the pre-processing the data set. While doing the pre-processing in our data, in our given data, first we'll see with that, okay, do we have how many of the categorical columns, how many of the numerical columns. Like you can consider location as well. Okay, Bangalore, or some Hyderabad, Pune, and Mumbai. Okay, Delhi, you can consider Jaipur, Chennai. Okay, see, while calculating the salary as well, okay, their salary structure will be different from the region to region as well. Okay, now as I told you, now I have taken the two features. Okay, now I've taken the two features, one is the experience and the location. Based on that, I'm going to calculate the salary. Now, okay, now what we do, as I told you, once I get the data, we need to do the pre-processing. So in the pre-processing, the first step is to see that, first step, even in the same approach, you can tell to your interviews as well. If when someone asks, like, and if I wanted to, can you explain me the data science, or like, can you explain the end-to-end approach of the machine learning problem, or can you end-to-end explain me about the model? Okay, if you want to build some model, how you are going to do that. So these are all the steps which we are going to tell in the interview as well. Okay, one is data collection. Okay, the second step is the data pre-processing. Okay, in data pre-processing, first step is to identify okay, number of numerical columns, numerical columns and categorical columns. Okay, next step is what is numerical columns and categorical columns. So this you can consider these numbers. If in our column, okay, which is having complete numbers, then we can tell that this particular column as a numerical column. When our data in our data, if there is an allocation, this is a one of the input column, right? This is a one of the independent features. So then if we see that some names, okay, some variables, some strings, if we can see that strings information, then we can tell that this is the categorical column. Okay, this is a categorical column. This will comes under into the categorical feature. Okay, column or feature you can consider. Okay, first we are going to identify the number of columns and number of categorical columns. Then, okay, why I will tell you, like, why the importance of to identifying the numerical columns and categorical columns. Okay, as I told you, the machines can only identify only which can consider the input as a numerical values only, numbers only. The machines knows only 0 and 1. If you try to tell that, like, hey, I am the Python programmer, the machine cannot understand. The machine don't know about the string information. If you try to pass, machine knows only the numerical values. Okay, that's why while before we are training to the model, we have to convert all the data, all the features to be the numerical. That steps will be performed in the data pre-processing. Okay, that is why we are showing you the first step is to identify the number of numerical columns and categorical features in the our data sets. Next, what we see next, we are going to see the missing values. So do we have any missing values in the data? Suppose in our historical data, sometimes, so some records might be won't available, some records might not be presented. Okay, we need to identify that which are the rows are the values are not presented. Like, if you see that, okay, suppose I have removed this 9. Okay, I have just given the salary experience, but I have removed the I've given the salary information, but I have forgot to give, or by human error consider that there is some information which is not presented. Okay, either it might be the programmatical error, either it might be the human error. Okay, but whatever the information which we have received, there is some values which is not presented. Okay, let's we revert to this 9. Okay, suppose you consider this value is not present, so we need to see how many of the what is the missing values also. So do we have any missing informations in our given data set as well? Okay, identifying the missing values, identifying the missing values. Okay, next what is another section will be in the data pre-processing is to do we have any imbalanced data. Okay, imbalanced data and considered in your target variable, okay. So imbalanced data means, like, in a classification, sometimes what will happen. Okay, so high or low which you are going to consider. Okay, this is your predictions you can consider. So sometimes the data which you are consider, most of the historical data, suppose you have a 10,000 data, 10,000 rows you have. Okay, so in 10,000 rows, that particular 10,000 rows having the both targeted variable of high and low configuration. Okay, high and low configuration. Now, in high and low configuration, 8,000 of values which are presented to the high information only, high output variable only. And the next 2,000 variables, next 2,000 rows will be having only 2,000 values. Okay, next low category values is presented only 2,000 values. If I'm teach with this data to my model, because my model has seen that many of the variables are looking as a high only, because my data, the high category data which is having more number of records compared to the low category. Okay, if I give something also, this always it will consider as a high only. Okay, so consider in our home, if we have any children's, okay, for a 1 year kid, okay, 1.5 years kid or 9 months of kid, if we show them the fruits like an apple, So they will identify through that by saying the apple, they won't understand. By they will identify through the color of the fruit. Okay, color of the fruit, they can see that red. Okay, whenever we give the red fruit as an apple, okay, apple fruit, because they identify that the color is a red. If I try to give some, strawberry or some other fruit with the similar color, they will think as an apple itself. Okay, because they have seen that many of times they have eaten the apple. Many of they eaten the apple because we have given the apple, that apple is in the red color. Okay, so when I give some other fruit with a similar color as well, they won't think that this is a strawberry or some other fruit. Okay, they will consider as a this is an apple itself. Okay, so when how will we tell them the based on the size of the fruit? Okay, this is apple or this is a strawberry or something some other. Okay, so with this way, which we can tell them to the our kids. Okay, this is the not to confuse. So similarly, in our data set also, if we always try to feed like in the higher categories having the more, like in the one category is having the more number of values, then other category will be having the low values, means our machine learning model will always predict the false positives. So that is very very dangerous for every AI model. Okay. So we always have to be, because you consider outliers. Okay, why I'm saying you this is a very important problem. Okay, you are working for some healthcare industry to identify the diagnosis of the patient will having the diagnosis. Okay, consider some the disease called as in a heart. Okay, which you need to predict the whether the person is going to be diagnosed with the heart attack or not. Okay, so if you consider that in your historical data, because you have seen that okay, most of the patients, okay, major of the data which is not having the diagnosis. Okay, so but for few users, they have suffered with the heart attack. So that information is there. So in the heart attack, we see that their BP values. Okay, what is their blood pressure, what is their sugar levels. Okay, and along with that, what is their heart rate for the time. Okay, and everything they will consider, and they can say that okay, this person is suffered with the fever. This is the data which we received. Okay, now consider here, majority of the data which is we have that the person will not suffer, and the loyalty of the data which is having the persons who suffered the heart attack. Now, because if I trained with this problem, even the person, because if I trained with this data, what will happen? Even there is a chances to have the particular person to have the heart attack. Okay, if I predict that this particular patient will be will not be in the diagnosis. Okay, the patient is not going to suffer the heart attack, means then think that how the model is making the false. Okay, if consider, because the person is going to be suffer the heart attack, but we are giving that this person is not going to suffer. Okay, so it will be the very problematic, right? So because of we have trained the many of the rows will be the uh, non-diagnosis informations. Okay, but if you are trying to predict the diagnosis for the real-time patients, it will be fail. Okay, so that's why we need to see that whether our data is having imbalanced or not. Okay, so we have to take in the equal number of the output variable, equal number of the each and every category. Then only our model, we can make our model to be more and more stronger and more accurate results. Okay, so we always have to consider while we are considering the data as well. Okay, one second. Let's see. Okay, for imbalanced data, we can say that like there are various techniques we have, like in a smoto technique and oversampling and undersampling. Okay, and oversampling and undersampling, and with these techniques which we can control the imbalanced data. Okay, and there will be the outliers. Okay, and another step is the converting to the data to the numerical features. So now we have the some categorical and numerical feature, right? As I told you that if in our input features, which is having the locations like in Hyderabad, Pune, Bangalore, and some numerical values. As I told you, the machine can only consider that numerical value. So these particular features which need to be converted to the numerical features. So for that, what we are going to do, so we are going to use first, for that we are going to utilize the one not encoder or label encoder. Basically, these features will help you to convert the categorical feature to the numerical features. Okay, so that's why we will use the one not encoder or label encoder, or based on our data set. Okay, if our data is in a tabular data, so we will implement the one not encoder or label encoder, or else we use that some TF-IDF vectorizers like in a word to vector, or like in a continuous bag of word models, and along with the glow technique. So we have various algorithms which we use. Okay, so next is that sometimes we are going to see the scaling part as well. Scaling approach as well. What it mean by the scaling? Consider in your input in your data set itself. So for the input features or some the output features. Okay, for few features which is having only one digits or two digits. Okay, but other features which is having four to five digits or six digits or seven digits. So when we wanted to, when we are doing the analysis with the future to features, we see the range as well. Okay, so the existing features which is having the two digits or three digits, and the other features which is having the six to seven digits or eight digits or nine digits, then is a huge difference. So this range, these differences which need to bring down, which need to be bring to the lower numbers. So in order to do that, we apply the scaling method. Okay, in standard scalar, or minimax method, minimax scaling. Okay, so these are the major scaling methods which we are going to apply. So this will comes if any number from the 10 digits or 8 digits, that will comes to the 0 to 1 range. Okay, 0 to 1 range. So there in the back end there will be applies the the various method, like in when I told you the minimax and variance, and standard deviations. So these particular mathematical equations which can be considered, and they will apply on this the larger values, and they will bring you to the lower values. So with all the features which will be into the similar set of range, to bring the similar set of range, we use the scaling method. So these are the six the steps which we need to which we need to be considered whenever you whenever you develop the model. Okay, this will comes into the data pre-processing. Okay, whenever, even in the interviews also, they will ask you, okay, one more features also you can sell that. Okay, future importance. Okay, identifying the futures as well. Identifying futures. Okay, it's we call as a future importance. Okay, so this future importance and other techniques can be done with the EDA, exploratory data analysis. The last week, which is explained by Ganesh and Lakshmi Narayana, Ganesh and Lakshmi Narayana, which is explained with the EDA technique. So, so with that EDA techniques, which we are going to do this the future importance concepts. Okay, so means like in out of 10 futures, which futures are providing you the to identify your targeted variable, or to identify your future prediction, because in your data there might be the 100 columns. So all the 100 columns which will not required for to identify our futures, right? Future predictions. Only the few futures which may require, that is 10 futures or 20 futures, that is columns are 10 columns or 20 columns or 15 columns. So we are going to identify the important features, that important features which will consider and will feed it to the model. Okay, so that we call as a future importance. So these are the basic steps which in interviews also they will expect you while you are telling to the for the model developmental activity or model development process. Okay, next step is that we'll implement this the data pre-processing steps. Okay, let's jump into the thing. Yeah, one second. Let me switch the screen. Just give me a moment. I'll just switch to the tab. Yeah, I hope everyone see my screen now. Okay. So first we'll import the package as in a pandas. Okay. If pandas is not installed in your package, so just click that pip space install. Okay, pandas. So it will install the pandas package. As we have already learned the pandas the last week as well, the pandas is a one of the package which will help the which will help you to do the statistical analysis. Along with that, if you are as you are the data scientist or as you are an a developer, so whenever we are working with the we have to work with the various data sources, right? So some data source will be the JSON, some data source will be the Excel file and the PDF files. Some data source will be the tabular TSV format, comma separated CSV files, text file. So in order to when we are working with various the data sources, so we required each and every time we need to install one package, right? Each and every time to import the one package accordingly the file which we are going to utilize. So but this pandas which will help you to handle all the various file. Either you can read the HTML file, you can read the JSON file, you can read the XML file, you can read the text file, you can read the Excel file, you can read the CSV file, any file which you can do with a single package. You don't require JSON, or you don't require the pickle, you don't require the OpenPF Excel or XLRD. All the packages can be implemented with this pandas. Okay, so that is the beauty of the pandas, because early 19s and 2000s, so there isn't a problem, because as a data scientist, if they wanted to do some future predictions, they have to work with various files. For to working with these various files, so we have to import the specific packages that makes the code to be more bigger and bigger size. Okay, so to overcome this issue, they have come up with the pandas library, which makes the developers, data scientists or AI developers works to be more easier. Okay, so my package is already installed, so that's why it's showing the defaulting. So let's import the pandas package now. Import pandas as a PD. Let's see the files. Okay, this is my directory. Okay, I have imported my pandas package. I'm reading my file now. Reading the file, reading input file. Okay, df read or something which you can keep. Okay, pd dot. You can consider this is my xlx file. Okay, so pd dot read underscore excel. Okay, I'm going to pass my input file name. Just copying here in the string. I have just readed my file. Okay, if you want to predict the if you want to display the 5 records of your input data, just keep that df.read head. You can say that. Okay, so this is the first for the futures. I think yeah, salary data CSV which I supposed to be considered. This is some other data. This is basically CSV. Suppose so for this is a CSV, so I need to change CSV. You can see that. Okay, now I loaded my the data set to the programmatically with the pandas package. Okay, now as we have seen that, okay, we are going to perform like we identify that this will comes under to the regression problem, because we have seen that salary as a continuous value, right? Now let's do in the data preprocessing. So first checklist we have seen that like can I identifying the categorical and numerical features in our data sets, right? So how will we do that? Let's see. To identifying the numerical features, anyone knows about how to do that? Can anyone ping in the chat? Okay, so here numerical values. Okay, I'm just trying to see that first how many of them in numerical values, because as you see in my data I'm clearly seeing that these are all the numerical, there is no categorical value. But even though, just we'll try to see, okay, how will be there. Okay, so df dot read, this is my pandas data frame dot read. Okay, select d types, data types. Okay, select d types, include parenthesis, include equal to integer 64, because if numerical values it might be the integer 64 or floats will be there. Okay, comma float 64. Okay, okay, I'm printing the column names now. So here you can see that. So here two numerical columns we have, right? Year of experience and salary. Even the system is also said clearly only the two columns only. Okay, let's see if there is any categorical columns which is presented in our data set. Columns equal to df dot read. Similarly, select data types. So here we are going to take is our the parameters in order to verify number of like to know the integer or the categorical column. So basically we take the object or category. So whenever we see the names in our data sets, that will be in the two data type formats only, object or category. Okay, so here you see the index is empty index here. There is no values in our index list, because it is clearly said that there is no columns only. There is no features which is belongs to the categorical column, right? So that's why we see the input information. You can verify with the, okay, you can see here length as well. Length of categorical columns. You can see 0. If I do the same thing with the numerical, you can see the two values. The length will be 2 because the two features which is presented, those two features belongs to the numerical values only, numerical data types. Okay, so we are clear. Then we no need to perform the label encoder, or we no need to perform any encoding label encoder step. Okay, one not encoder step, because these six checklists are mandatory, but only if required we are going to utilize. Okay, but we need to know the knowledge of each and every feature. Okay, each and every step. Okay, that's why I'm showing you whether the step will be required to utilize or it is not required. Okay, so as for that, here we no need to require the one not encoder or label encoder, because here we don't have any names, we don't have any categorical or object columns. Even you can verify with that df dot read. Okay, info, with the info also you can see the data types. Okay, number of features, number of columns, and number of rows are presented and belongs to which data type as well. Okay, even sometimes if there is any missing values, you can see the missing values as well. Okay, even if you want to find out with the programmatically df dot read. Okay, so we'll see that like whether we have any missing values. See, is na dot sum. So for two columns we don't have any null values as well. If we have a null values in our column, so we apply the statistics. If in our data, if in our data if we have missing values, okay, missing values, then we'll apply, okay, statistical methods like mean, mode, okay, and median, weighted mean. Okay, so these are the basic 4 steps which will be applied. Okay, there are other steps also which can be considered, but basically these are the 4 standards methods which will be applied. Okay, when we see any missing and when we see some records are not presented in the data, so based on the statisticals method which we are going to do, so to implementing the statisticals method, we use a scikit-learn package. Okay, scikit-learn is the scikit-learn package. It can be utilized, it can be implemented to the machine learning algorithms. And along with that, when we see that if any features which we wanted to convert to the numerical features, we can use the scikit-learn. Okay, so you can see that if I import scikit-learn, I just have to comment, this is the basic doc string, right? Okay, then if you see the scikit-learn, by using the dr inbuilt keyword, you can see that what are the operations can be performed with this scikit-learn. So these are the various operations can be performed. So data set, you can see that suppose like there is iris data sets or some other predefined data sets will be there, right? So those data sets also you can directly import with this data sets by using this data set, the operation. So you can consider the dummy and ensemble approach. Ensemble means like, and as I told you, random forest or something, bagging and boosting algorithms if you wanted to apply, or like in random forest algorithm if you wanted to implement, you are going to use an ensemble based. Ensemble is nothing but the multiple algorithms. If you are using multiple algorithms together, more than 2 algorithms, we call as a ensemble method. Okay, and you can see the future extractions, future selections. Okay, and along with that you can see the linear model. Okay, to implement the linear models like in a regression algorithms which we are going to use this linear model, inside the linear models we can see the polynomial regression and simple linear regression, and we can see the the svr regression. All the regression techniques can be presented here. Okay, which you are going to see that. And you can see the other the features as well: pipeline, neural network, neighbors, navy base, and all the structures will be presented here. Okay, so let's jump into the topic. And even these imputers can be applied with the pandas also, which we can do that. Okay, by using the mean, replacing with the mean or mode, by consider wherever the missing value is there, we can replace as well. Okay, fill any, we can in pandas, what we do in pandas, okay, pd like in a tf dot read. Okay, and dot read fill na, fill null values with the sum value. If you want to replace some null values with the one, or if you want to replace null values with the sum approach, you can pass the particular value. It will replace the wherever the null values, wherever the empty rows is presented, with this value will be replaced. Okay, that is the fill na method which we'll use generally. Okay, so now coming back, there is no missing values also in our data, which is we are clear. Then another step is, okay, the other step is, okay, identifying missing values is there, and we need to see the imbalance data. The imbalance data can be only seen in the, when we see the categorical features, then we can consider the imbalance data. So we don't require the missing imbalance data as well here. Let's jump into the other thing. Okay, now once we import the data, another the step is very important is that, so we need to split the independent and dependent features. Okay, as you see here, this is the year of experience is the only one feature which we have the independent feature. The salary is the dependent feature, that is the targeted variable, which we can say that. To split the data, to split the data into the independent features and dependent features, we use the iloc method. Okay, we use the iloc method to split the number of features. So let's run. Here I've taken as an incorrect variable. Okay, I have executed. Now if you see that if I print x, you can see only the input features, that is a experience. Okay, you can see the various values of the input features. Okay, so now if I print the y, you can see the the salaries. Okay, this is X you can consider as a independent futures. Okay, we are splitting independent and dependent futures. Okay, dependent features, that is called as a target variable, also dependent features. Okay, this is your final outcome. Okay, so now you see that once you identify that, you can split the independent and dependent variables. Then okay, once you identify the independent and dependent variable, because we don't have any information as well, so here we can split the data, in our any model. Okay, to train the model, okay, we have to know that if you have an 100% of data, 70% is for training, and the remaining 30% of the data we need to be considered for the test and validation. Okay, so because the once the model is trained, we have to train that, we have to test the data set, right? So that test information, for to do the test of the model knowledge, we split the data into the X train and Y train. So 80-20% or 70-30% you can consider. If you wanted to see like in the validation side as well, you can consider, you can split the test data, 20% of the test data you can split into the 10-10 as well. Okay, here I'm splitting the data to the 1/3, that is means 70 and 30 ratio. Okay, so to split the data, we can use the scikit-learn package. So in scikit-learn, you will be having the operation called cross validation. With the cross validation, you can import the train and test and split. With the train and test split package, with the train and test split method, you can split your data into the two parts, that is the training and test part. Okay, so I have employed, and here I'm passing the X and Y variables, input and output feature. I'm giving off my text size as well. Okay, if you are mentioning text size or train size, if you mention one variable, accordingly it will calculate the, okay, how much of the training size says training data size should be there, how much of the test size that should be there. Okay, and while splitting, you wanted to split the data in the randomly, or you want to do the sequentially by row, or by picking from the one is from the the first row, one is from the 42 row, or one is from the 15th row. If you wanted to pick like in a randomly, you can provide the random state value. Okay, let's execute here. Okay, this particular value which is deprecated here, scikit-learn. Okay, module is not found. Let's see. Pip install. Okay, this package is already installed, but I see that there is an issue with this one. Let's see. Okay, okay, this might be the this package might be the deprecated. Instead of the cross validation, okay, we use the model section. Okay, with the model section also we can perform. Okay, let's see. This itself, it is not working. Okay, let's restart. Sometimes the cache might be takes in the Jupyter notebook. Let's restart and we'll load that. Okay, okay, it is working. Let's see. We'll comment and we'll see this package. Yeah, why this issue is happening? Can anyone guess? Like in my Python version 3.13, this is the latest version. If we take the latest version, so these might be the issues we might be encountered. Let me switch with the For 3.12, 3.12, I'll stop the terminate here. Okay, just give me 1 second. So I'm taking the 3.12 now. I'm switching to the 3.12. Let's see. Okay, I'm trying to install the Jupyter notebook. Sometimes this issue might be happens. Okay, let's see. It takes just 2 minutes of time to set up this Jupyter notebook, and then we can run the server so that we can see that latest changes as well. Okay. So I'm trying to set up this Jupyter notebook. Okay. So let's just give me a moment. So here you can see the Python 3.12 I'm taking now. I've just switched the 3.13 to the 3.12 because this scikit-learn it's not supporting this model selection or the cross validation approach. Let's come down because whenever we take the latest Python software, this particular model will be not updated as per the latest version. So it takes some 6 months to 1 year. So we are just downgraded to the 3.12. That's why. Okay. Let's see. Just give me 2 minutes of time. Once we finish up with the Python program, like in implementing the machine learning end to end, then we'll see try to implement with the Excel as well. Okay. So in Excel, like we go with the deeper like doing of all the mathematical calculating the constraint and the coefficient values, everything which you're going to see. Like you can see that. So each and every mechanism, like in each and every the functionality which have to calculate it by ourselves with the R squared, like in TSS and RSS, residual sum of square and total sum of square. Okay, let's see with the Excel approach as well. Once we finish up with the Python program, it's just updating. Just give me a moment. Even we can try to make the model to be without training and without splitting the data also I can show you the demo, but just because as we need to know as a process like whenever we before training to the model we have to split the data into the two parts like in our three process based on the requirement, but basically we do the train and test split. So the 70 and 30 is that is the range which minimum which need to be considered. If we go with the 60 or 50 to the training size, the model will be not learned as accurately, because if the amount of learning we do, then only we can tell them the answer with perfectly right. The similarly, the amount of the data you feed to the model, the training data, the model will be more accurate, okay, for predicting the futures. Let's run the Jupyter. Okay, let's switch 1 second. So we have successfully run the Jupyter server. We'll switch to the notebook now and we'll see the difference. Okay, we came back. Oh, I've given incorrect. Let's implement the install the scikit-learn. It's setting up the scikit-learn. Okay, just give me a moment. Yeah, it is installed. The package is installed. You can see that my Python version is 3.12 now. Okay, let's rerun. So now the issue is disappeared. See that? Oh, still that issue is coming. Okay. Okay, let's see that. I'll see that why the issue is appearing again and again with the model selection as well. Let's see what is happening. Just give me a moment. Okay, that model version it might be varied. Okay, let's see. 1 second. Yeah. Okay, model selection itself it is not there. Okay, we'll see that model selection if it is not there. Inside the model selection, yeah, we have train and test split. Okay, let's see. Okay, it is working now. Okay, so here I've given so incorrect model section. I've taken the selection in place of selection. I've given some incorrect name. So that's why we are seeing that. Okay, I'm so sorry for that. Okay, let's jump into that by splitting the method. Okay, here in place of x, we have given the we have to run for above one as well, right? Okay, let's read. Let's read the data of. I have to install the pandas as well. Just give me a moment. This is new environment. Just don't think that like in a 3.12 which is there, but this particular environment which I've created for specific for the training, so I have not installed the packages, because if it is an anaconda or some other setup which can be directly, these packages are inbuilt. But when you are trying, when you install Python software alone, you have to install all the packages based on your requirement. Okay, that's why I'm setting up all these packages, so by creating the new virtual environment. Just give me a moment. It is setting up. It is installing the packages. Yeah, it is done. Okay, let's rerun. Yeah, it is loaded. Okay, data set which is not available here. 1 second. Let me copy that. Let's give the full path. Here data is readed now. So just running the numerical values, then validating. Okay, we have taken the input and output features. Then simply we are implementing the scikit-learn package with to split the data set, train and data split. Yeah, you can see that now. Shape x10 is 20, and total shape also, if you can verify. Okay, x dot shape. Okay, 30 total. 30 is our rows. Okay, number of the data values are presented in our data set is 30. Okay, I'm splitting the 70 and 10, 30. So 20 and 1, which is came. Okay, y shape is also, you can see that. Okay, and x list. Okay, 10. Okay, so now let's see. So we have splitted the data into train and test. Now we are going to implement the machine learning model. Okay. Okay, here I'm skipping one more step. The scaling factor, I will show you without scaling and with scaling, what will be the different. Okay. So I'm applying the linear regression. You see that in scikit-learn to implement the linear regression, as I told you that just use the linear model. From there, you can import the linear regression. You can import the logistic regression. You can import the decision tree. This is a simple way implementing the linear regression. I'm importing my linear regression. Okay, linear regression class, and from to call the class, I'm initializing the object is called as a regressor. With the object, I'm calling my the class. Okay, so then I'm using the fit is nothing but here you to train the model. To training the model, we use the fit method. Okay, fit generally used for to train the model. Then I'm passing the input and output data, that is x train and y train, to my model. Okay, just I'm running, so you can see that. Okay, here in linear regression, just I'm used the 3 lines, only 2 lines. I've imported my package, and I provided my input and output data to the linear regression. The model is trained, that's all. If you want to see what type of the features are presented in the linear regression, this particular method, shift and tab, if you press, you can see that all the inbuilt features, these are the inbuilt parameters which we can be provided. Number of jobs or positive or fit intersect. Okay, all this information can be seen here. So when you pass empty, that can be taken as a the constant values, which is predefined values. These are the predefined values. You can tune accordingly your requirement based on your data set. Okay, so I'm taking the constant values here in my model. I've trained my model, which you can see here. Okay, now I'm going to test my models. Okay, so suppose considering, if you wanted to predict, if you wanted to see the new values, which is if you wanted to see the new values, okay, that can be tested in the X test. Regressor dot predict. Okay, this regressor is the one which we have used to train the model. You can use the model also. Model dot, the model is the object which we defined to call the linear regressor. With the model object, we have used the fit method to train our model. Okay, so then I'm using my model to predict the new features. Okay, these are the new features, y predictions. Okay, by for providing the x test data. X test is the experience values. You can see this for these experience values. So these are the salaries which has been predicted by the machine. Okay, the model which we train. Let's see in the original values, that is y test. Y test, these are the original values for these experience values, 37731, but here we have 40546, and you can see that 122391, but here we can see that 122682. Okay, which is near, which is almost near as well. Okay, but you can see that 64813, but here you see the 57. This is huge difference, seven, almost 7000, which is different as well. Okay, so like that you can predict you can see the predictions of your model by using the predict. Okay, and there you can use the metrics also, r square, to see the predictions for the model by using the metric method. This is how you can train your model and you can predict the new features by passing your input data. Okay, this is how generally we do the machine learning. Okay, whenever you wanted to create any new model, we collect the data and we do the data pre-processing, and then we predict. Okay, let's see. Okay, I performed without scaling, right, these values. Let's apply the scaling factor. Okay, if I'm doing the standardizing values, like, because I've given the input and output features, with the one is the single digits and two digits, and another the targeted variable will be the 5 6 3 4 digits as well. Let's see. Okay, because here you see that I have not converted anything. Okay, which is directly I have passed here. Okay, so now we do the standard scaling here. Let's apply the standard scaling. Again, one more issue. Expected 2D array, and this is the issue. Okay, we can resolve this one. Okay, sometimes when you are trying to do the data processing, these are the common, the kind of issues which you will encounter. So that is good that if we see the more issues, then only we can learn that, okay, how to resolve these issues as well. Okay, let's see. Just it is expecting that to reshape our module. Okay, let's do the reshaping. See, that issue is just gone. I've done the reshaping with the numpy. Okay, then the issue is resolved. You can see that now. If I do extrain, see my extrain values, the experience, which are two digits right now, it is came to the 0 and 1. As I told you, which are into the below two digits only. Okay, if you see the white train, you can see all the values also 0 to 1 in the range itself, in the single digits, which I can tell that. Okay, so now let's make this data to the model, like we are retraining our model now. Okay, you can see that. Let's take in the another variable to see the difference. Okay, so now we can convert also this one. So here I've given y test and x test. Yeah. Okay, this, if we can redo that, then we can convert to the original values. Okay, so with that we can predict our standard scaling. Okay, so we can improve the more accuracy side as well. Okay, let's see into the slide. Okay, these are the basic 4 steps, as I told you: predicting the test set and training set results. Okay, this is what we do, that model training. Okay, simply only with the 2 lines and 3 lines of code, you can train your model, and you can fit to the model as well. Okay, so there will be the no work only, like an as a simply which we can utilize, and we can do that. Okay, so let's jump into the slide, and we'll try to analyze. Okay, like that we can implement for all the algorithms. There is there is nothing much difference. I will teach you in more algorithms, like the implementing with the decision tree, and bagging and boosting and random forest. But today's for is linear model. Let's quickly review in the Excel as well. Okay, see, you have input and output values. Okay, for consider for the same issue only, let's take, not with the other approach. Okay, hours and scores. Okay, so if you are even in the Excel, we can perform the machine learning, right? So like using the machine learning with the latest Excel features, which is having machine learning techniques also, to analyze your data as well, see, which you can see here. Okay, and if you wanted to see that, like in how in the background it will predict these features, means, as I told you, this will comes with the y equal to mx+c, right? So you have not implemented anything, any single line of mathematical operations in your code here. Okay, just you have imported the package and you have created the object. With the object you have passed the input variable xtrain and ytrain with the fit method, and you have trained. Then you simply, by using the predict method, you have predicted your values. Okay, now but actually in the backend what will happen, as soon as you receive these futures, okay, as soon as you receive these futures, okay, yeah, so as soon as you receive the futures, it will go and it will try to identify that the mx+c formula. Okay, so how will calculate the mx+c? So it will take off the each and every one. So to do that, okay, m you can consider this is b0 and b1 which is there, right? So you can consider y equal to mx+c. Okay, to calculate the m value, that is the coefficient value, what we required, this is x minus x mean. The x cap is nothing but the x mean. Okay, into y minus y mean. Okay, x minus x mean into y minus y mean divided by, okay, x minus x mean, x minus x mean square. Okay, the square, x minus x mean of square. Okay, this is the formula we use to calculate the m value. Okay, so this is the program which the program it will calculate, and it will give you the your interest with the coefficient and slope value and everything. Okay, intercept value as well. So x minus x mean into y minus y mean into x minus x mean square of x minus x mean of square. Okay, so to calculate, first we need to calculate the x minus x mean square, right? So suppose you have one feature, that is hours and scores. You consider the experience and salary. Experience, you are going to take the x minus x mean. Okay, let's apply here itself. Okay, here you will apply x minus x mean. So for what we do x minus x mean, first we have to take the average of this one, average of your input feature. Okay, equal to average of your input feature, that is 2 to up to your here. You can select, you can get the average value is 5.31. Even in your program also you can verify that, like any intercept and coefficient values as well. If you see that DAR, yeah, if you get the intercept, like in a model intercept, you can say this is your intercept value. Okay, like that you can see your coefficient value as well. Okay, so the same value which we are performing in the Excel now. Okay, this is the coefficient value, that is nothing but the constant. This is the intercept value 6. Okay, so we are going to calculate that intercept value with the formula of x minus x mean of into y minus y mean by x minus x mean of square. Okay, let's do that now. Apply x minus x mean, right? Like a2 equal to a2 minus, okay, and this average value. Okay, see, this is the x minus x minus x mean value which is there. Okay, like that we are going to calculate all the values, or you can directly pass this value also. What is the 5.31667, right? 31. Yeah, it is extended. By clicking that, you can see that second value also for a3, a4, a5, a6 and a7. Okay, now I calculated my x minus x mean. Let's calculate the y minus y mean now. Okay, so for that what we do, first we need to calculate the average value of our salary as well, right? So here equal to average of my salary value. Let's select from here to here, b2 to b31. Okay, this is my average value, 75815.13. Okay, equal to y minus I'm sorry, b2 minus my average value of y. Okay, let's write it is instead of copying 81.513. Okay, let's do that. Okay, it is came y minus y as well. Now, as I told you, there is a x minus x of square which is there, right? X minus mean of square. Okay, so we have x minus x variable, right? By squaring of this value, we can get the e column value as well. Okay, so for that, let me see the formula. Yeah, c into c, c2 into c2. Okay, let's see. So now we got the x minus x one as well. Okay, now let's calculate. So first I'm calculating the first value of x minus x into y minus y, because now I got x minus x and y minus y as well. Okay, so let's implement x minus x mean into, oh sorry, into minus y min equal to that is c2 into, okay, d2, right? This is the formula, right? We are doing for c and d for in a multiplication x minus x into. Okay, now we got, okay, now what we are going to do, we are going to do apply the y equal to mx plus c formula, right? So let's do 1 second. I'll switch to the another window. One second. Yeah, perfect. Okay, then we are going to do the y predictions. Okay, now we are going to do the predictions. Okay, that is y predictions you can consider. This is how we have implemented all the steps, right, with the scikit-learn. Just we have called the linear regression, we have used the fit method, then we have trained our model, then we have used the predict variable to be passing the x test values, we have seen the salaries. Okay, now let's implement with the predictions here equal to, okay, so f2 divided by, okay, f2 divided by e2. Let's say this is how the predictions. Okay, y equal to mx plus c, right? Like, let's see, we need another value as well. Okay, to do the y predictions, it's not only y equal to mx plus c, right? We have to do that. This is just intercept formula only. Okay, let's write here m equal to, this is m of x minus x mean of y minus y mean divided by x minus x mean of square. Okay, so this is only for calculated for m value. Okay, so now we need to calculate the m value here. Okay, we'll take off all the values here. Okay, yeah, we'll take the sum of this one to implement equal to sum of equal to sum of d2 to d31. Okay, because here we have negative values and everything, right? So that's why here let's take sum of d2 to d31. Okay, point one which just came. Let's see e column equal to sum of e2 to e31. Okay, this is for the x minus x square and y minus y. Let's take this the sum value for this as well. Like x minus x into y minus y, we need to take that, right? Okay. F2 to F31. Okay. Now we got all the values. Let's do yeah. Now what we are going to do for, once again, this is the formula for Excel, right? So f is it, this is our value. Okay, equal to f3 divided by x minus x square. Okay, this is the one, f33. Oh, this is a e33, because e33 we need to do, yeah. This is something calculation has happened. X minus x3. Okay. Okay. Yeah. This is our coefficient value which is came. Okay. So basically here I've done the y in notebook we have seen that our coefficient value is 9, right? But if you see here we are seeing that 9, right? 9,000. So here, because I've done this standard scaling, let do the without standard scaling so that we can see that our intercept value. Okay, let's go back. Yeah, you can see that the coefficient value clearly 9,333. Okay, yeah, it is almost here, like with the Excel based we are doing, right? So that's why it's 9,459 it is came, the coefficient value. But the intercept is 26546. Like we need to calculate that as well. Okay, now how will we do? Let's take the formula of previously which I implemented. Yeah, this is the formula. To get that, see, this is something which I'm showing you because this is mathematically what we do, which we need to know. Now m value, which we know that like in a 945 945,984. Okay, because to make the predictions we need to know all these values. Okay, that's why I'm calculating the intercept and coefficient value. Okay, first we have calculated the coefficient, now we are doing the intercept c value. Okay, so here m into x. Okay, x of mean, this is mx is nothing but x mean. Okay, x cap you can consider. Okay, don't confuse. So what is the x mean? X mean is the 32 value here. Okay, so here I'm going to take the mean of this one, 5.31667 place. Okay, so I'm doing, I'm trying to do the c value, right? So here I'm trying to calculate the c value. So in my formula, what will happen, this will convert it to the c equal to, I'm just moving this y minus mx. Okay, mx minus c equal to m x mean, mx mean minus y mean. Okay, this is basically y mean only, no need to confuse this one. What is this one? Okay, y mean equal to mx mean plus c. So now I've changed my c variable to here and I moved the y variable to here, interchange the position so that I can calculate. Now here what I do, I'll make the my y mean. What is my y mean here? 75815. 75815. Yeah. Okay, let's apply this formula. Okay, yeah, here you can see 25041. Okay, I've taken the reverse, but that's why it came. So here you see the 2645546. This is the concept, that is the intercept, the constant value which I told you, which is almost all similar only. Okay, so you can change this one to, okay, here what we can do that. Yeah, 2501. Okay, now we need to apply here each and every variable we have to predict, right? Y equal to mx plus c. Now we are going to predict the new features. So for that, this is my m value. Okay, so m value will be 9459. Okay, this is 42 cell. Which 42? D42 equal to D42, or even you can write this one directly. That might be the better. 9459 945984. Okay, this is my m value. Okay, into the x value, this is x2 which I'm going to pass here, because each and every record which I need to predict, right? So I'm passing the m. Next place, see what is the c value here. We are here, I calculated 25041, 25041.8. Okay, so now let's make to the equal to here. This is the your future prediction. Let's do this. So let's see. Okay, okay, this is something which I need to do like this. Okay, yeah, you got into it. Okay, Yeah. Oh, here it is came. Everything is same only. 1 second. Let me change it. What is happening? Let me see. Here all the values are same only. This is incorrect actually. 1 second. Let me correct the formula. If we are performing the machine learning model, the analytical through the Excel, that's why we are seeing the little complex. Let me correct this one. See well. 25014.8. Yeah, you can see that the formula is applied here. Now the values are changing, so you just need to correct it. Let me take here this one. Okay, let's implement here. Yeah, you can see this. All the values has been changed now. Okay, so here this is something which is one mistake. This is the y predictions. Okay, so this is how we'll do y equal to mx plus c. You can see that. So in the mathematical, if you wanted to perform the core Excel, like and this is we calculate the intercept and coefficient, then we apply this formula. Okay, this is about the linear regression. So to calculating the future predictions. That's all from today's session. If you have any doubts, just do let me know.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.